living organism, you need certain conditions in order to what? Survive and what? Grow and what? Reproduce. So microorganisms, different microorganisms have different what? Conditions. There are some microorganisms like the gonorrhea bacteria or the AIDS virus. If you expose them into the atmosphere, they will not last more than what? A second, and they're dead because the atmosphere condition is not what? It's not good for them. That's not the environment they need to survive. They're gonna die. If you look at gonorrhea bacteria, if you bring it out into the air, it will die quickly. But because it needs a moist environment, which is either in the vaginal canal or in the what? In the urethra or the penis. That's what those conditions are good for. If you look at virus loves tissue, it has to be in the tissue. If you bring it to dry, it's gonna die. So every you as a human being, if I put you underwater, are you going to survive? No. But if I take a fish out of water and bring it to the earth, is it going to survive? So we all have different conditions in order to survive and to grow and to reproduce. So microorganisms, this particular geobacillus, has certain conditions to what? To survive and to grow and to reproduce. And those conditions is what this machine is what? Providing. If I take this geobacillus like this and crack it and put it here, it's not going to do anything because the environment here is not suitable for it. If I want this thing the organism to react, I have to give it what? The conditions that is appropriate for its survival, growth, and reproduction. And the conditions that this guy needs is what the machine is what? Providing. So if your control doesn't test positive, two things. Either the guy's already dead before you put into the machine, or the machine is not what? Working properly. Why? It's not giving the organism the conditions that it likes to grow and survive and reproduce.
Alright. The control is testing now. It's testing so the machine is working on.
It's testing. No. It's testing. Okay. It's testing if the BI is what? It's alive. It's not dead.
Yes, alive.
Yes, that's the control.
Yeah. And the machine is.
And the machine is also working properly.
So in case the result shows that it's negative.
The BI, the control.
So
the control.
Yes. It means that
when it shows negative, if it shows negative, then you have a problem. Either your machine, the incubator is not working well, or the guys are dead.
So that's my question. How do you conclude which one is the result?
Okay.
That's one of the questions.
Then the next one you're going to do, the conclusion, before you draw that conclusion, you're going to have to run another test. Take another, so they come in a pot. So take another one and put it in there again. Then it's also dead. So now we have to find out which is which. You're going to look for another incubator. Okay? And then what? Test it in there. One. So if I take one from here and I test another incubator and it works, then I'm suspending the incubator is not what? Working properly. But if it doesn't work in the next incubator, then chances are that the guys are already dead. And I'm going to have to call the company and tell the company, look, they all have serial numbers. This batch, this is what is going on. And the company will look at it and give you an answer. Any questions? The incubator provides conditions necessary for the organisms to what? Grow, survive, and reproduce.
So that's only does like
that's its mission. When a newborn baby, a preemie baby, don't you think we put them in the incubator?
Yeah.
Their lungs and everything is not well developed to survive the self-sustaining breathing that we do. That's why we put them into what? The incubator. And the incubator provide them conditions for pre-made to what? Survive. Without the incubator, you bring out that you're gonna what? For their lungs and others are not well developed. So the incubator, the job of the incubator is to provide conditions for the organisms to what? To survive, one. to grow, to and possibly to reproduce.
So do you have to put that in a sterilizer?
Which one? You are not listening. We have how many BIs am I talking about? What are the two? Control BI and what? Test BI. So we have two. Which one is going into the machine? The test. Which one is not going into the machine? The control. What is the test measuring?
Whether the machines are able to tell
Microorganism. What is the control measuring?
to know whether the cells are alive or not.
And then
Whether the incubator
it's working well. That's all. Alright, but you're gonna know more when we go into the next chapter. So control management. If you are using this BI, if you are using remember I said Bowie-Dick test you can only do it in what type of sterilizer? Dynamic or prepper. Gravity you don't do Bowie-Dick because air is removed what? Naturally. The function of Bowie-Dick test is to measure the ability of your machines to remove what? Air. Air is removed naturally by gravity sterilizer, so you don't need a Bowie-Dick test. Let me ask you a question. So I'm saying that do you need to do a Bowie-Dick test in a gravity sterilizer? No. Now the next question. Do you need to do a BI in a gravity sterilizer?
No.
Listen. Do you need to do a BI in a gravity sterilizer?
Yes.
Huh?
Yeah, you got to do the BI test in the gravity sterilizer.
So answer my question. Do you need to do a BI in a gravity sterilizer?
Yes.
Yes.
Do you need to do a BI in a pre-back sterilizer?
Yes.
Yes.
Why yes for both?
Because you got to make sure that the machine is...
In both of them, you are measuring if they can kill what? Spores. So you have to do BI for both. But when it comes to Bowie, you only do it on a what? Pre-back or dynamic area because that's where the man-made mechanism you are trying to test is. It's not in the gravity. Got it? Okay. Now, how do you do the test? It's an empty chamber. You take the pack. This is the pack. The pack is this one like this. You put it on the lower shelf over the drain. We'll talk about the anatomy of the steam sterilizer. They should have brought the first chapter, the next chapter before this chapter, because the next chapter explains more than this chapter. But we'll talk about that. At the bottom over the drain, and then you run your this thing, your BI. That's what they're talking about here. The lower shelf over the drain. You will get it. These are examples. These are from different companies. This is Verify, Geringer, Sporting, Side. This is 3M. I use 3M. We have the blue tab and this is for gravity sterilization, and the brown tab is for high vac. Okay. These are all some of the tests. See what the question the guy was asking, Gilbert, what did he tell you? So you use for what? Steam sterilization. That's what they showed me what there. Air removal test. What's the name of the air removal test? No. What is the name of the test? Bowie-Dick test. And what is the function? It detects if air is not removed properly. It also detects air leaks. So the Bowie test does two things. Is air being removed properly, or is air leaking? The air should not leak into the chamber when it draws a vacuum. So it detects air leaks and inadequate air removal. And at the last one, you see that says steam and air cannot occupy the same space. That's what I was talking about. Here's our friend. So So if they ask you what is the function of a Bowie-Dick test, measure air removal and detect air leaks. And which chef, see that? What is it saying? Pre-vacuum steam cycles what? Only. This example of a Bowie-Dick test. It's yellow like this. If the machine is removing air, everything will change to brown to black evenly. If some part is black and some part is yellow, it means the machine is not removing air effectively because the part that is yellow, there were air pockets so the steam could not make what? Contact. Did the test pass or fail? This one.
Yeah.
This one.
Yeah.
Pass or fail?
Yeah.
Why did it fail?
That's a yellow,
Huh?
yellow stripe.
Where's the yellow stripe?
In the middle. Yeah.
You sure? Did you see yellow stripe in the middle?
Yeah, yellow. That's a yellow.
This one? It looks yellow?
Black.
Huh?
Brown, yellow.
Do you see any yellow in there?
Yeah, that's yellow.
Huh?
Yeah.
Like bench.
Brown and yellow.
Where is the yellow? Look at it. Look at yellow here. Do you see any yellow like this in here? Okay, let's look at it. I don't know what is the next one. Let me see if there's a fail one. It didn't show a fail one, but actually that one has passed. If it were yellow, if it has failed, you're gonna see either yellow at the center or yellow at the edges. It looks you know because of the effect of the light, it looks some yellowish along the edges, right? But this is the pass. If the color changes evenly to brown, it's good. If it's a mixture of yellow and brown, it has failed. That's the whole different companies are different. Okay, so now let me look at the next one. I've already explained this. What is another name for the physical monitoring? The physical monitoring is the same as the no, this one. What is this one? MI. Yeah, mechanical monitoring. That's the physical monitoring. When the process is going on, it will be recording it, printing it out. So you can see it doing it, and then after you have to check to be sure, you know, the data or the conditions that need to be there have been what accomplished. That's what he's talking about. And every cycle gives you its own what? MI. That's what he's talking about. When the cycle is complete, you check it, that the required conditions have been met, then it's documented, and then it's a legal document, because anytime you are in a lawsuit, that's what you're going to use to prove your case. That's what he's talking about over there. See this example here. As the process is going into the printing, it gives you data, the cycle data. Okay, and this is what I was talking about. These are all mechanical, it's part of the mechanical. The gauges will be measured. We have two types of gauges. We have the jacket gauge. See, I'm gonna flush it over, and you're gonna understand more when we move to the next chapter, or when the new master can, because it's gonna eat all my time. But we have gauges. The sterilizer. The sterilizer is designed this way. It's designed this way. It's designed like this. And then another one like this. It's designed like a chamber within a chamber. Okay? And then it's like this. And this is the door. Okay? So it's a chamber. This chamber inside another chamber, but there's an opening around it. The opening around is what we call the jacket. And this is the chamber. of the sterilizer. Alright, it's like, you know, if you look at this cabinet, it's like putting another cabinet in there, but you have this space around it. You understand what I'm saying? The space around it is called a jacket. And if the door is open, if it's empty, there's nothing inside the chamber. But the jacket, there's always steam inside the jacket to keep the chamber warm. And they have gauges because we have to measure steam pressure. So we have jacket gauge. It's like this, and it's 0 all the way to 30 pounds. And then we have vacuum, which is measured in inches all the way to 20 inches mercury. And at any particular time, if it's well calibrated, the jacket, the pin, the indicator should be pointing at 30 pounds. Because there's steam in there. Remember I said we need 30 pounds pressure in order to get a sterilization temperature of 270 degrees Fahrenheit. And when sterilization starts, the pressure in the jacket and the pressure in the chamber should be what? The same. Okay. So when the chamber is empty, there's no steam here. This is the jacket gauge. This is the chamber gauge. The chamber gauge. Okay. Let's look at it this way. This is 0, 30 pounds. This is vacuum, 20 inches mercury. This is the pin. If the chamber is open, there's nothing in there, the door is open. Where do you think the pin of the chamber gauge should be pointing? Zero. You're pointing at 0. Because there's no what? Steam in there. It's measuring steam what? Pressure. You know what is pressure? It's the weight of something upon the surface. So if there's no steam in there, then the chamber jacket will point to 0. But there's steam in the chamber gauge. But then there's always steam inside the jacket. So always, because there's steam in there, there's pressure, steam pressure in there, to be pointing to what? 30 pounds. At the time when you start the process, steam leaves the jacket and comes into the chamber. And after conditioning, the steam will break pressure up to what? 30 pounds to equal here. So at the time of sterilization, the pressure inside the jacket and the pressure inside the chamber is the same, which means both pins will be pointing at what? 31 pounds. When the process is complete and steam is moved out of the chamber gauge will move back to where? Because there's no what? Steam. So those are the gauges. So we have gauges. The gauges measure the pressure of steam. And then the display screen, that's this screen here. It should be telling you what is the conditioning phase, the temperature, the pressure, and all those things. To be like a display screen of your car or of your cell phone, right? Same thing. So this one here, it gives you visual impression of the process going on. Once the process stops, it's no longer what? There. So this one, it gives you a visual impression. This one here, that's this. The graphs and the computer printouts give you the actual what? Hard copy of what was going on. You understand what I'm saying? This, while this is going on, the machine, the printer will be printing everything. As the process goes, conditioning. When it's done, and then we tell each time the temperature and the pressure and the vacuum. When it's done and you go to sterilization, you tell it tell it sterilization. After sterilization at 10 o'clock, you give me 3 minutes. So it is going. At 10:03, it stops. And then you're going to do evacuation, 2 minutes. Then it starts, then it's going to go dry mode, then be recorded dry mode. Then it's going to tell you, this is the highest temperature rate, this is the lowest temperature, exposure time was 3 minutes. The whole process took me what? 45 minutes. And that's to keep that for your record because you need a hard copy. You need an actual printout of the cycle data as proof if there's a problem that the process was what? Properly executed or it was successful. Alright? So that's what you see over there. Printouts, that's what you see over there. Some are in glass, some are in printouts. Pressure, chamber, now I'm not, you see, the chamber and jacket what? Same during exposure. That's what I say. You see here 27 years because it's a range. Between 27 to 30 pounds of steam can give you a temperature of 270. So what is this one? What is this? The printer. What are these? Gauges. Okay, this is at 0. So most likely it's going to be a chamber one. Gauge. Okay. And what is this one? Split screen. And as it's going on, you can see. As it's going, you can see like your car. As you drive, you're going to see the odometer, right? The odometer or the speedometer. The pin, you're going to see going, you are going 60, you're going, and then once you take your leg off the gas, then it starts coming what? Back. Same way. So that's the printer. I'm not going to go into these details because we're going to do that when we do the lecture. But this here, you see here, this is telling you payback. It means the sterilizer is a payback. What is the difference between a payback and a gravity? No, I don't want that answer. I want it better put. What is the difference between a gravity and a hard payback?
Gravity is natural.
Natural what?
Natural.
Air is, put it simple. What did you say?
Air is removed naturally.
Oh, but use the right terminology. Air is moved by what?
By nature.
Put it right, I want the right terminology. Air is moved by what?
Gravity.
Gravity. Air is moved by gravity. And then the payback, air is moved by what? A man-made what? Mechanism. It could be a vacuum pole or air removal system. So here it's telling you it's payback. Cycle started at this time on this.